Okay, let's look at a couple of other harder examples of proving an identity. We need to be keeping our eye on these two just to make sure we know which one we're going to use. Now looking at simplifying this first expression, well, I've got sine squared, and if you've got a squared trig function, it looks as if you're probably going to be using this one. In order to be able to use it, I need to take that 5 out as a common factor. So I'm going to remove the 5 as a factor. It's going to be 1 in the middle minus sine squared. And then, just like the last example we did, if you've got 1 minus sine squared, that just leaves cos squared. So 5 over there, and then it's cos squared theta. And that's simplified. Okay, for this slightly harder one, I'm just going to move that up a little bit. You need to decide which one you're going to start on, if you're going to start on the left side or the right side. Now, from experience, you're going to be able to do more with this side than the right-hand side. So I'm going to replace my tans with this guy over here, so I can do something with those. So tan theta on the left-hand side is the same as sine over cos. And then plus. When I have 1 over tan theta, well, that's the reciprocal of tan theta. And if I take the reciprocal of sine theta over cos theta, I'm just going to get cos theta over sine theta. So that's going to be upside down. Look at I. There you go. Okay, so now I've got two fractions added together, but I don't have a common denominator, and my aim is to try and put them together by the end of the identity. So I'm going to find a common denominator, which is going to be the product of these two on the bottom. So hopefully I can get everything over sine theta times cos theta. Plus something. Okay, right, now let's look at the numerators. So the change on the bottom of this fraction has been to multiply by sine theta, so I'm going to do that on the top as well. And sine theta times sine theta makes sine squared theta. And for same reason, sine theta has been multiplied by cos theta, so I'm going to do that with cos theta on the top as well, and that makes cos squared theta. Then I've got a common denominator between my fractions. I'm going to add them all together, add the numerators, keep it green, or blue even. Sine squared theta plus cos squared theta. You're probably ahead of me now once you've seen that. Sine theta cos theta on the bottom. And then my blue numerator fits exactly with this identity up here. Sine squared theta plus cos squared theta is 1. So 1 in the numerator, and if you look at the right-hand side, you're done. Ta-da!